Hello friends, today we are going to discuss the new topic, that is GNF form, that is Greibach normal form. First, a grammar is said to be or in the form of a GNF when a grammar will be a context free grammar. Means if a grammar G has to be in GNF form, then first this grammar will be satisfy the context free grammar properties. Okay. So, for GNF form, a context free grammar is in GNF form, that is Greibach normal form, if all the production rule that must satisfy one of the following condition. And what are the conditions? The first condition is that a non-terminal generating a terminal value. That means if we have a grammar like this, A, capital A derives small b, this means this A is a non-terminal and this B is a terminal. So if a grammar is in this form, then this grammar is in GNF form. The next condition is that a non-terminal generating a terminal followed by any number of non-terminal. For example, if a grammar is like A derive small b, then D1, D2 up to Dn. Okay. So, where A is a non-terminal, small b is a terminal, and D1, D2, Dn are the set of non-terminal. So, this terminal value is followed by any number of non-terminal value. Then this form or this grammar is said to be in GNF form. And the third condition is that the starting symbol generating a epsilon, means if S is the starting symbol and S derive epsilon, then it is also said to be in GNF form. So, a grammar is said to be GNF when the grammar is context free grammar. If a grammar is context free grammar, then if one of the following condition satisfy for the context free grammar, then that context free grammar is said to be in GNF form, that is Greibach normal form. Okay. Many times the question comes that a grammar is given to you, that a grammar is a context free grammar and you have to convert that context free grammar in GNF form. So, there is an algorithm, or you can say some steps, which is used to convert context free grammar into GNF form. So, what is the algorithm? See here, the algorithm to convert a context free grammar into GNF form. So, the first step is that we have to remove all the null production. Second, we have to remove unit production. Third, remove all the direct and indirect left recursion. And fourth is do proper substitution of production to convert it into proper form of GNF. Means, first you have to check that a grammar is a context free grammar. Okay. If a grammar is a context free grammar, then you use these steps. So, the first step is that we have to remove, if there is a null production exists in the grammar, then you have to eliminate it. So, what is the null production, how you remove that null production, or what is the unit production, how you remove the unit production. We already discussed these two topics in my previous video. So, go through that video and then come here. Okay. So, these topics are already covered. Now, the third step is that we have to remove a direct or indirect left recursion. Means if a left recursion exists in a context free grammar, then before moving ahead, we have to remove that left recursion. So, what is left recursion means? First we discuss. Actually, recursion are of two type. Recursion are of two type, left recursion and right recursion. What is left recursion? Okay. If a grammar is in the form of like this, that is A derive A, alpha or beta, then it is called left recursive. Why? See here, if leftmost symbol of the right hand side, if the leftmost symbol of the right hand side is equal to the left hand side, then it is called left recursion. So we can explain like this: if the leftmost symbol of right hand side of the production, okay, if the leftmost symbol of the right hand side of the production is equal to the left hand side, then it is called left recursive. Okay, and right recursion, if the grammar is in the form of A derive alpha A or beta. So in this, the rightmost element of the right hand side of the production is equal to the left hand side, then it is called right recursive. So this means rightmost element or rightmost symbol of right hand side of the production is equal to the left hand side, then it is called left recursive. So recursion are of two types, left recursive and right recursive, but in the GNF we only have to check the left recursion. So if the left recursion, or if the grammar is in this form where the leftmost symbol of the right hand side of the production is equal to the left hand side, then the left recursion exists. So if left recursion exists, so we have to remove the left recursion property. So how we remove that left recursion from the grammar? See here. As we know that the left recursion, this left recursion is in the form of A derive A alpha or beta. So in order to remove this, that the leftmost symbol of the right hand side of the production is equal to the left hand side, so if in order to remove this, we have to convert is in the form of A derive beta A dash, okay, and this A dash can be epsilon or alpha A dash. So this is in the form, if we have to remove the left recursion which is in the form of this grammar, then we have to convert it that A derive, this is beta, so beta A dash, and this A dash can be epsilon, or this is alpha or A dash. So we will take one example in which we eliminate left recursion. Suppose we have example like grammar like E derive E plus T or T. Okay. So see here, if this E is the leftmost symbol of the right hand side is equal to the left hand side, then this grammar is left recursive. So we have to eliminate this left recursion. How? First we separate the grammar is in the form of A, alpha and beta. So this is A, this plus T is whole is alpha and this T is beta. Okay. Now we have to convert is in the form of like this, that A derive beta A dash. So see, in order to remove the left recursion, what is A? A is E here. What is beta? Beta is T. A dash means E dash. Okay. And this E dash can be first epsilon or alpha. What is alpha here? Plus T A dash, that is E dash. So this is left recursion, and how this is how we remove the left recursion property from a particular grammar. Okay. So in order to convert a context free grammar into a GNF form or Greibach normal form, so first we have to remove the null production, second we have to remove the unit production, and third, if there is a left recursion property exists, then we have to eliminate that, and after that we have to do some proper substitution of production in order to convert in the proper form of GNF. What are the form of GNF? That a non-terminal generating a terminal, or a non-terminal generating a terminal followed by any number of non-terminal, or the starting symbol generating a epsilon. So if one of the following conditions satisfy for a particular grammar, then that grammar can be said to be a Greibach normal form. Okay. So we take one example and check how we convert this context free grammar into GNF form. Okay. So first, if the example is S derive XA, capital X, capital A, or BB, both are capital B. This B derives small b, or SB, X derive B or A derive A. Okay. So, first we have to check whether this grammar is a context free grammar. Yes, this grammar is a context free grammar, so we have to move ahead. Now the first step is that we have to eliminate the null production. So see here, till now the grammar do not contain any null production, so we skip this step. Now next step is remove unit production. See, there is no unit production exist here. Okay, so we move ahead and take the third step. Now remove all the direct and indirect left recursion. So see here, is there any grammar is in which where there is a left recursion property exists? No, there is no left recursion, so we move ahead. Then the last step is that we have to a proper substitution of production to convert it into the proper form of GNF like this. See here, this S derive X and A. So these X, S, X, A, B are terminals. Sorry, you can say they are non-terminals. So here non-terminals are S, X, A and B. Okay. So for a grammar to be in GNF form, no grammar will contain consecutively two non-terminal. They are in the form of some like this. A non-terminal contain a terminal, or a non-terminal contain a terminal followed by a set of non-terminal. So this means that this form or this form means S derive XA, S derive BB or B derive SB. They are not in the GNF form, and remaining grammar are in the GNF form where the first condition satisfies. So we have to eliminate all the non-GNF property. So how? First, we replace or we substitute this S derive XA or BB in this S. Okay. So we replace S derive XA or BB in B derive SB, because this grammar is not in the form of GNF because there are two consecutively non-terminal. So in place of S we substitute this grammar. Okay. How? See here. First we take this grammar S derive XA or BB as it is. Then we consider B. So B derive small b, no problem. Now in place of S I have to substitute this value of S here. So in place of this S I have to first substitute XA and this B as it is, or in place of S we write down capital B and this capital will remain as it is, and the remaining grammar will remain as it is, that X derive B and A derive A. Okay, no problem. Now still there are many grammar which are not in the GNF form. So then again check, there is a null production? No. There is a unit production? No. There is a left recursion? No. So we move ahead. That is the last fourth step that we have to substitute. So replace or substitute. Now we have to substitute X derive B in where X in this grammar or in this grammar. So this means S derive XA, or we substitute this X in B derive XAB. So first we take S. So in place of this X we take X derive B. So in place of X we write small b, capital A or BB. Okay. Now from this grammar capital B derives small b, or in place of X we substitute this value B, A, B or 3 times capital B, and the remaining part is X derive B and A derives A. Okay. So after substitution in 2 steps, still there is some grammar which are not in a GNF form. So we check whether the following conditions satisfy or not. So first is that there is no null production. Okay. There is no unit production. No. Okay. but there is a left recursion property exists. Where? See here, the left recursion is capital B derive capital B and capital B, and the remaining derivations are small b or BA B. So see here, the leftmost symbol, this capital B, the leftmost symbol of the right hand side is equal to the left hand side. This is the left recursion property. So in order to remove this left recursion, see, the grammar are in the form of A derive A alpha beta. So we have to convert it in the form of like this. So this is A derive A alpha or beta. So in order to eliminate this, we have to convert it A derive beta A dash, or A dash can be epsilon or alpha A dash. See here, in this case, this is A, again this is A, this is whole alpha, this is beta 1 or this is beta 2. Okay, there are many production. So in order to eliminate this left recursion, okay, we can take A dash, in place of A dash we take another variable, that is C. Okay, so first A derive beta A dash. So this can be, in place of A, what is A here? This A is B. So B can be beta. So first we take beta 1, then we take beta 2. So for beta 1, this is B. A dash, in place of A dash I am taking C here, capital C, and then A dash is C, because I am taking, in place of A dash I am taking C. So C will be epsilon or alpha. What is alpha here? Capital B, and this A dash is C. So this is for beta 1 production. So for beta 2, it can be, first we write beta, so that is B, A, B, then A dash, this is C. So in place of C, again C can be epsilon or BBC. This means that for this left recursion, to eliminate, while eliminating this left recursion, we find these two production after eliminating the left recursion property. So now the answer is, after removing left recursion, after removing left recursion, okay, now the grammar will be S derive, this grammar will remain as it is, B derive BA or capital B, this B can be, now in place of this I am writing this, because this grammar will be treated as that there is no left recursion property exists. So this B can be small b capital C or small b A B C. This C can be epsilon or capital B or C. Then X can be B or this A can be A. Now still there are some grammar which are not in the GNF form, where this is capital B or this BBC. So we have to eliminate this property. So in order to eliminate, again we check whether there is a null production. Yes, there is a null production exists. So before moving further, we have to eliminate null production, and null production is C derive epsilon. So for removing the null production, first of all we have to find out all the nullable variable. Nullable variable are those variables which are directly or indirectly generate the epsilon production. So see here, if for this particular grammar, what are nullable variables? See, nullable variables are, so in order to eliminate the null production, first we have to find nullable variables. We already discussed this topic in detail in my previous video. Okay, so nullable variables are those variables which directly or indirectly generate the epsilon production. So C derive epsilon, this C is directly generate the epsilon. So the first nullable variable is C. Okay, and then check, is there any other nullable variable which are indirectly generate the null production? No. So this means for this particular grammar we find out the nullable variable, that is C. Now the second step for the elimination of null production, that we have to observe this nullable variable, that wherever they encounter in the grammar, so we have to rewrite that grammar with that nullable variable or without it. So how we can do it? The grammar is see here. So we have to eliminate this null production with the help of this nullable variable, that is C derive epsilon. So see the first grammar, S derive small b capital A, so there is no C here, then capital B no C, so we will remain as it is. Now B derive small b and capital C, so in place, so this is C is a nullable variable, so we have to write this production with this nullable variable and without the nullable variable. So first we write with the nullable variable and then we write without nullable variable, that is only B. Okay. Now the next production is B derive B, A, B, C. Again C encounter. So we have to first rewrite this production with C and then without C. So this is B capital A and small capital B. Now for this grammar C derive epsilon, so we have to avoid this, and then we check next grammar C derive BBC. So again this C encounter here, so we have to eliminate this BBC. First we take this grammar with C and then we take B, and the remaining grammar is X derive B and A derive A. So this is how we eliminate the null production. Now again check, there are some more grammar which are not in the GNF form, that is this or this, okay, this. So again we have to eliminate while moving ahead. First we check there is a null production, no. There is a unit production, no. There is a left recursion property exists, no. So again we have to substitute in order to eliminate those property which violates the GNF form. So here first we replace this B with all the B grammar. So substitute or replace this B, okay, this B. First I am substituting this capital B and this capital B in C grammar, in C. So how? See, so first B S derive BA or BB remain as it is. Now the capital B will be BC or BABC or BAB, okay. And again there are some third step also in the null production, that we have to eliminate that nullable variable. So in order to take the third step, you can cancel out this production or this production also. Okay, now substitute this C as in this B, in place of this B I have to take all the production of B here one by one. So first in place of this B I am taking B derive BC, so this BC and the remaining BC, or in this in place of this B I am taking B small b, so BC. Now in place of this B I am taking this production, so BABC BC, or this production BABBC. So for this particular production we have to substitute the capital B grammar and take this result. Now in place of this B, okay, so you can take this grammar continuously or you can take another grammar. So I am taking in the same grammar. So in place of this capital B you have to substitute this value. So first I am substituting BC here, so it will be BCB or BB or BABC and this B, or BAB or B. Now check all, and the remaining grammar will be X derive B and A derive A. Now check whether all the grammar are in the GNF form. See here, this is in GNF, okay, this is not in GNF, this is GNF, 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 all these grammar are in the GNF. So remaining one grammar which are not in GNF, so we have to substitute again this B value in the S production. So replace or substitute see, substitute the value of b in s. So s derive, small a and capital A will remain as it is. Now in place of this first b, capital B, we have to substitute all the 4 production one by one. So first is B, C, B, or small b, capital B, or small b, A, B, C, B, or small b, capital A, capital B, B. Okay. Now the B production will be BC, B, BABC, or BAB. C production will be BC, BC, BBC, BABC, BC, BAB, BC, or BCB, or BB, or BAB, CB, or BABB, and the X derive B and this A derive A. So this is the final answer or final grammar, see, which is in the GNF form. Check one by one. This condition will be first, this is second, this is first condition, this is second, this is second, this is second, okay, this is first, this is second, this is second, 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 this is second condition, this is first condition, and this is first condition. So all the grammar will must satisfy one of the following condition of GNF. So this is how we convert a context-free grammar into a Greibach normal form. So I hope you have understood all the following property, or how we eliminate null, how we eliminate unit, left recursion, or how we substitute all the values. Okay. Still, if you have any query, then you can ask in our comment section, or you can send your query directly to our business email ID, that is itechnicallearning@gmail.com. So keep watching our video. Thank you so much.